On the screen, a side-by-side diagram shows several ethene molecules on the left and one long chain labeled polyethene on the right, and the aim is to understand how alkenes form addition polymers. A close-up focuses on the carbon-carbon double bond with the electron pair highlighted, and the explanation says that opening the double bond creates two new single bonds that let molecules link head to tail. A process card then shows general conditions such as high pressure, moderate temperature, and a suitable catalyst because these conditions help the double bond to open and the chain to start and grow. 3 ethene molecules are drawn approaching one another, and as the double bonds open, the carbons join to give repeating -CH2-CH2 units, forming a saturated chain. The text points to the small molecule called the monomer and to the segment in square brackets with bonds that pass through the brackets called the repeating unit that builds the polymer. To draw the repeating unit from a monomer, we remove the double bond, keep the 2-carbon skeleton with all side groups, extend bonds through square brackets on each side, and write a small n outside the brackets. To recover a monomer from a repeating unit, we copy the 2 adjacent carbons with their side groups, draw a double bond between them, remove the bonds that cross the brackets, and keep the atoms in the same order. A naming card highlights that the polymer name is poly, followed by the monomer in brackets, so ethene gives polyethene, propene gives polypropene, and chloroethene gives polychloroethene. Example panels then show repeating unit structures of polyethene, polypropene with a CH3 side group on one carbon, and polychloroethene, also called PVC, with a green chlorine sextituate. Another example shows tetrafluoroethene, CF2 equals CF2, converting to the repeating unit of PTFE, with fluorine atoms on each carbon and the name polytetrafluoroethene. A property card links the saturated backbone and different side groups to material behavior by noting that polyethene is flexible, polypropene is tougher, and PVC is rigid and a good electrical insulator. The closing slide reminds us that many addition polymers are unreactive and often not biodegradable, so recycling and responsible use are important, and it recaps the drawing and naming rules shown.